start of a new year. What's up guys, it's Kayla
and Jim,
and welcome back to another Meteorology Monday, or Tuesday, or whenever this video finds you. But wait,
hold on. It's not staying.
Happy
New Year!
It is currently January 1st and we are filming the first video of the year.
That's right. We are so excited about some of the topics that we want to cover for this year, so just stick around. And you know, if you're not subscribed already,
what are you doing? Hit the subscribe button. And while you're at it, if you find yourself enjoying this video, be sure to leave a like along the way. What are we talking about today?
Today we are going to talk about the 2008 Parkersburg, Iowa EF5 tornado. Now, this event was really interesting, real interesting case study in how it formed, how quickly it formed, where the majority of the devastation occurred, and then how it ended. So we'll get into all that in just a minute. But again, this was one of those case studies that we had put up as a survey, and you all said, yes, we want to see this one too. So we're going to do that today.
Let's get into the meteorological setup for the day.
On the afternoon of May 25th, 2008, a surface low-pressure center was located over central Minnesota. A warm front extended eastward from the low for a short distance, then abruptly turned southward through central Iowa and northern Missouri. A cold front extended southward from the low center through west central Iowa, then southwestward into Nebraska and Kansas. A prefrontal trough was also present across central Iowa, out ahead of the cold front. At the 850 millibar, or roughly 5,000 foot level, south-southwesterly winds were drawing up ample low-level moisture, while at 500 millibars, or roughly 18,000 feet, there was enough positive vorticity, counterclockwise spin, to introduce cyclonic motion, thus leading to additional ascending air across that region. At the 300 millibar, or roughly 30,000 foot level, a jet streak with maximum winds between 90 and 100 knots was moving in from the west. This would lead to additional rising motion due to diverging winds aloft, like a venting of the winds at higher altitudes.
With warm moist air below and lifting mechanisms moving into place, causing rapid upward motion, the stage was now set for the tornadic event that would soon occur.
Forecasters across the area were concentrating their efforts on a triple point located over south-central Minnesota. This is an area where the warm front, prefrontal trough, and cold front converged, causing significant rising motion as well as rapid turning of the wind with height. However, as the afternoon progressed, the focus expanded further south as the environment became increasingly favorable for tornadoes over north-central Iowa.
In fact, the destabilization over central Iowa was noted as changing from a cool, cloudy air mass that morning to the warmest, most humid afternoon of the spring season. For example, that morning in Marshalltown, Iowa, about 37 miles or 60 kilometers south of Parkersburg, had a temperature and dew point at 7 a.m. of 59 degrees Fahrenheit and 55 degrees Fahrenheit respectively. By 4 p.m. Central Daylight Time, Marshalltown would report a temperature and dew point of 84 degrees Fahrenheit and 70 degrees Fahrenheit respectively. Around 3 p.m. Central Daylight Time, a cluster of thunderstorms formed rapidly along the dry-line prefrontal trough in an area of highest instability near Fort Dodge, Iowa. Cape values were near 3,000 joules per kilogram. South winds at the surface veered to west-southwest aloft. Forecasters observed numerous thermodynamic and wind shear values were well within the range of concern for strong and violent tornadoes. At 3:30 p.m., the Storm Prediction Center issued a particularly dangerous situation tornado watch, number 363, for much of Iowa, including Butler and Black Hawk counties, which included the city of Parkersburg. Their discussion reads, "Very to extremely unstable air mass across much of Iowa ahead of the cold front. Thunderstorms will develop rapidly, and with strong deep layer shear quickly become supercells. Very large hail and tornadoes are likely with any supercell. Potential for long-lived supercells with strong tornadoes. As the cluster of storms continued moving eastward, they caught up with the north-south oriented warm front, and storms developed rapidly over Iowa as predicted by the Storm Prediction Center.
So we've got the atmosphere set up in where we have warm, moist air at the low levels. We have cooler air aloft. We have a turning of the winds to veer out of the south-southwest to a westerly motion, a west-northwesterly motion. So you got your rising and your rotating components there. And the instability really was in that range for strong supercells to form tornadoes. A lot of things coming together, and especially focusing on a triple point that was mentioned. You had that low pressure center, you had the warm front, the prefrontal trough, and the cold front extending out from there. So that's usually a good indication for not only a rapid turning of the winds with height, but you've got temperature contrast there too, you know, with the clouds and then the sunshine breaking out, so you've got temperature variations. And so I can understand how they could focus more over Minnesota, but definitely as time went on, they were starting to observe things further south into Iowa that was priming all the more.
Yeah, as we talked about, SPC kind of put their finger on the map there at the triple point and said something significant is going to happen today. They issued their PDS tornado watch, and they were really keeping an eye on the events that were about to unfold. However, where they were currently focusing on was a little bit outside of where the EF5 of the day was actually going to take place, as we're about to see here in a minute with the storm specifics.
One of the links that we will put down below in the description is a paper done from Sarah Monette. I'm sorry, Sarah, if I butchered your last name, but it was a really good paper. She goes into great detail about how this event set up and the possible indications from the morning setup to the afternoon setup as to why the focus shifted from south central Minnesota down into Iowa. So we'll have that link down below. You can take a look at that too. So let's go ahead and get into the storm specifics. At 4:22 p.m., the National Weather Service in Des Moines issued a tornado warning for northeastern Grundy, northeastern Hardin, Butler, and southeastern Franklin counties. At 4:46 p.m., the National Weather Service would update its warning to include northern Grundy and southeastern Butler counties, which included the cities of Aplington and Parkersburg. Around 4:48 p.m. Central Daylight Time, the storm produced a tornado near the Butler-Grundy County line, 2 miles south of Aplington, Iowa. The tornado grew quickly in size and intensity as it moved east-northeastward towards Parkersburg. At 4:51 p.m., the National Weather Service issued an update to say the tornado would be near Parkersburg by 5 p.m. Around 4:56 p.m., the tornado entered the southwest corner of Parkersburg, traveling eastward along Highway 5714. It would destroy homes, businesses, 2 banks, and the high school. At 4:58 p.m., the National Weather Service issued an update to say the tornado would be near New Hartford by 5:10 p.m. At 4:59 p.m., the tornado widened to 3/4 of a mile wide as it moved through the southern part of Parkersburg. The tornado grew in strength to an EF5, causing extensive damage on the east end of town. A wind row of debris was observed in open cornfields east of town. The tornado then struck large grain silos filled with corn just east of Parkersburg before traveling through the river bottoms, uprooting and snapping hundreds of trees. The tornado continued to churn eastward, maintaining its size and EF5 intensity.
At 5:04 p.m., the National Weather Service issued a tornado warning for northern Blackhawk and Bremer counties, including the northern portion of Waterloo, Cedar Falls, and areas north of Dunkerton. At 5:09 p.m., the tornado moved just north of New Hartford, causing significant structural and tree damage to a housing subdivision, destroying more than a dozen homes. As the storm moved east of New Hartford, the tornado weakened and narrowed its path to about 100 meters, turning abruptly south and then resuming an east-northeast track. South of the tornado track, The storm developed significant straight-line winds that produced estimated 90 to 100 mile-per-hour winds. The tornado made 2 more abrupt turns to the southeast prior to reaching Highway 63, passing just north of Cedar Falls in Waterloo. At 5:37 p.m., the Waterloo Airport recorded a wind gust of 93 miles per hour, and straight-line wind damage caused severe damage to a recreational vehicle dealership north of Cedar Falls. The tornado suddenly grew in size and strength, widening at one time to 1.2 miles north of Dunkerton, causing EF2 to 3 damage to a farmstead around 5:51 p.m. Within minutes, the tornado would weaken and lift southwest of Fairbanks.
In summary, there was EF5 damage to portions of Parkersburg and areas north of New Hartford. Maximum winds were 205 miles per hour. The average width of the tornado was 0.6 to 0.7 miles near Parkersburg. The maximum width of the tornado was 1.2 miles near Dunkerton. The path length of the tornado was 43 miles or 70 kilometers. There were 6 fatalities and about 70 injuries. Although the tornado remained on the ground for approximately 43 miles, 98% of the track was over rural farmland. However, it was at the beginning of the event where the tornado was at its strongest and did the most amount of damage as it traveled through Parkersburg to New Hartford. A large number of vehicles were damaged and breached by flying debris. Thus, they would not have been good locations to ride out the tornado. Spiral ground markings observed within cornfields showed this was a multi-vortex tornado. There were sudden changes in direction, and the sizes and shapes of the spiral ground markings changed dramatically within a few tens of meters. So what's really interesting about this case, about this tornado specifically, is how rapidly it formed in the beginning and grew in strength and intensity at the beginning of the storm. And unfortunately, it was at that time was when it moved into a populated area like Parkersburg. So that's where, you have more homes and businesses and the high school, everything being damaged, destroyed. Of course, you would get good indications of wind speed for the EF scale because it's actually hitting something, which we'll talk about a little bit, as it's going through Parkersburg and New Hartford. What also was really interesting was as it's going through some more rural parts of town and rural parts outside of that, you see these spiral markings in the cornfields that was indicative of multiple vortices, abrupt changes in the direction of the tornado, just things going on there that wasn't your typical, the tornado just, drops down, goes in a certain path for a certain distance and then lifts. This had a little bit more going on to it, so it was very interesting.
Yeah, something that is very, for lack of a better word, cool about this event is how it went through the rural areas and left those spiral markings so we could actually study what was going on in the tornado. And we learned a lot from Parkersburg as meteorologists about how tornadoes can rapidly change their size, even though if they're going through towns and stuff, you might not be able to see that. In the swirl patterns on the ground, you could see the change in width, how many vortices there were. Also, as it was going through Parkersburg, obviously since the EF scale is a damage scale, whether it should be or not, it is a damage scale. So as it's hitting buildings and stuff, it is gaining that EF5 rating. But once it moves out of areas like that, there's no way to accurately rate it an EF5, but you can still see the things that are going on in the cornfields.
That's right. And so once it moved outside of New Hartford, the width of the tornado shrunk down. I think we mentioned about 100 meters. Was its size, and then it grew in intensity again as it approached a farmstead near Dunkerton. Of course, the width was much more there. Again, all the markings,
doubling, yeah.
The markings on the ground and some other things to help identify that. So, is it possible that there was still 200-mile-an-hour winds between New Hartford and Dunkerton? It's possible, especially with multiple vortices and, what's the winds going on inside the vortices that are going around the, tornado proper. Unfortunately, the EF scale only is a damage scale, so we don't know
But we did have the straight line winds that were observed,
Yes.
which is caused by downbursts and winds going outward, so it's not part of the tornado, but it's from the storm. And those were a little bit less than 100 miles an hour, so you still have these significant winds coming from the storm, even if we can't accurately rate what the tornado is during that time because it's not hitting buildings. We still know that the storm itself is producing at least 100-mile-per-hour straight line winds. Last thing I kind of want to touch on for this tornado is how it did significantly damage a lot of vehicles. And it's sometimes in the movies, you know, people will get in their cars and try to outrace tornadoes, and it's kind of shown as these safe places to be, but Parkersburg is a great example of how your vehicle is not actually a great place to be during a tornado.
Not only looking at a vehicle from the perspective of the tornado can pick it up or flip it over and roll it for hundreds of yards, but looking at it from a standpoint of it's going to get bombarded by a lot of debris. And that's what was observed with vehicles in this tornado's path, was these vehicles were bombarded with all sorts of debris penetrating the windows and other areas of the car, so it wouldn't have been safe in the car even if the tornado didn't hit the car directly.
Right.
So that's something to also consider too when it comes to these kind of storms coming through.
Yeah.
On top of that, the chaotic path of some of these tornadoes that, again, if they're not going in a straight line and they just abruptly change, you know, and you're in your vehicle and you're caught unaware, that's what makes storm chasing so
hazardous, dangerous,
challenging. Dangerous. Exactly. You know, so you have to know what to do, and whenever, on personal experience, whenever we go chasing, in the back of our mind, number one priority is always safety, right? So as she's looking at the radar and I'm driving to get us there, I'm also thinking in my mind, okay, as we're getting there, we need an escape plan at the same time. So we could get out, film the storm, but as she's doing the filming, I'm looking for our next route, our escape plan, and get to our next location. So it kind of cuts that, you know, time where it would be spent, you know, looking at the tornado. Unfortunately, it's spent more me looking at the map too, but it keeps us safe, and that's how we roll. So
there's a lot of times that we've sacrificed getting certain pictures and footage and stuff because number one priority is making sure that we can get out of a dangerous situation to chase more storms. And this one was in 2008, but a great example of how erratic these tornado paths can be is El Reno in 2013, where unfortunately it was very public. Everybody kind of knew from there that these tornadoes can take different paths. And some tornadoes do go in a straight line, but we're just kind of touching on the ones that don't currently. So there you have the May 25th, 2008 Parkersburg, Iowa EF5 tornado. Again, if you like what you saw, be sure to hit that subscribe button and thumbs up. Helps us out a lot, doesn't take much of your time. While you're at it, check us out over on Facebook and Instagram. We post all of our weather adventures over there, and our School of Weather. If you're interested in learning about the basics of meteorology or severe weather or things that kind of go along with storm chasing, check us out over there. The link for that will be down in the description.
And don't forget, we've got a couple of storm chasing videos here too as well that you can check out.
That's right, they'll pop up at the end of the video. So until next time, I'm Kayla.
And I'm Jen.
Thanks for watching.
And we'll see you at the next Meteorology Monday.
EF5 tornado.
Good job.
Thank you. It took me a second to like...
A lot of information in that one sentence.
Every time you see me say that in every other video, it's normally the 6th take of me trying to say it all.